So let's go ahead and begin with a warm-up question over the domain. For this question, there's two things that you have to be concerned about. You have to make sure that inside of a square root, we're not allowed to have any negatives, so this has to be greater than or equal to 0. And we have to also make sure that the denominator does not equal 0. So there's two things we must consider. For the first thing, 2 minus x greater than or equal to 0. And we do have the or equal to part on this because it's the numerator, the top part of the fraction, so it's okay if it is 0. If we solve this, we actually just could add the x over, and we get x is less than or equal to 2. I often like to switch this around just so the x is first. If we just sort of reverse this, this becomes x is less than or equal to 2 in that way. Just make sure the opening is still facing the 2 there. So that's all we have to do for the first part. X is less than or equal to 2. For the bottom part, we set this equal to 0 and solve it. And we get 5, so this is saying that x cannot equal 5. So you have to consider these two conditions. This one says that x must be less than or equal to 2, and this one says it can't be 5. Well, this one we can actually throw out because this one says it can only be numbers less than 2, and 5 is actually bigger than 2 anyhow, so we don't even need to worry about that condition. So this is the only condition we have to worry about, and we're just going to write that in our interval notation. So less than 2 would be negative infinity up to 2, and we can't include 2 because it has a line under it, so we're going to do a bracket. So that is our domain. Today we're going to be talking more about functions, and we're going to call this section the library of functions, meaning we've talked a lot about some properties of just basic functions. Today we're going to talk about several functions that you just need to know what the shape of them looks like, what their domain and their range is. Functions, again, you just have to know, oh, this is what this function looks like. So I would write all these down. These we could also call our parent functions. Okay, our parent functions. Meaning this is going to be the general shape for any of these functions. And then if we were to do some transformations, which we'll do in the next section, that will affect, might move our function up and down, might stretch it a little bit. But this is our parent function, or sort of our shape that we're going to start with, and then we might modify it from there in the coming sections. So the first one we're going to talk about is the square root function. Just f of x equals the square root of x. And if you need to pause this, maybe when I'm done with this particular function, maybe pause it, write all that stuff down. But I'm going to move through each function. Again, after each function, if you want to pause it, write this slide down, and then the next one, same thing. Watch me explain it. Pause it, write it down. Might be a good idea. So the square root function, the way that we're going to come up with these shapes is we could just do a little plugging them in for this one. You don't need to make these tables, but just kind of show you where this comes from. First of all, if we were to just say plug in 0, we plug 0 into the function, then we get out to 0. So there is a point at 0, 0, because you can take the square root of 0 at 0. If you plug in 1, square root of 1 is 1, so there would be a point at 1, 1. And now the next one, 2 would not necessarily be a good number to plug in here because you would get the square root of 2, which is a decimal. So that's actually not a good choice to plug in. If you're thinking logically, the next good number to plug in would actually be 4, because the square root of 4 is 2. So if we went out to 1, 2, 3, 4, up to 2, that would be a good point to plug in next. The next one after you that would be 9. 9 would be a good one because square root of 9 is 3. But this is fine here. We just want to get the general shape. It looks like this. So it starts at 0, it's dot on 0, and sort of has this general shape moving out here. All right, so the domain of this function, the square root function, well, notice there's nothing in the negatives, right? This is all the negative direction over here. This is the positive. There's nothing in the negatives, and that should make sense because we know we can't plug negatives in. So the domain starts at 0, it'll be a bracket, 0, because we can include 0, to positive infinity, parenthesis on infinity. The range, remember that's the y coordinates. Well, the lowest this function goes is actually 0 in the y direction too. Now this is going to continue. Notice how it's increasing, it's going up, right? It has this shape. It's going to eventually get all the way up to positive infinity because it's going to keep going up and up, never levels out completely. So it will go all the way up to positive infinity. The x-intercepts, where does it cross the x-axis, which is here? The only place is at 0, right? X equals 0. And y-intercept is also at y equals 0. It's the only place it crosses. Now again, in the coming sections, we're going to modify this a little bit. We might do square root of x plus 2, and that would actually shift it up, and so it would change the y-intercept, and it would change the domain and the range. But this is our parent function, all of our sort of stats about our parent function. The next one is the cube root function, the cube root of x. So again, if you need to go back to the last one, pause it, write this stuff down, move on to this one. All right, the cube root function, if we were to take a similar strategy as we did on the last one, if I were to plot some points, just to show you where we come up with this, let's start with 0 again. Plug in 0, and the cube root of 0 is 0. So put that at 0. If we did 1, cube root of 1 is 1. So 1, 1. Now also, you can plug in negative numbers into cube roots as well. So if I were to plug in -1, I actually get out -1. So that's going to be here. Now the next number to plug in, 2, again, wouldn't be a great choice because you'd have the cube root of 2, which is not a whole number. So the next good number to plug in is actually 8. Because when you plug in 8, the cube root of 8 is actually positive 2. So we're going to go out to 8 in the x-axis, 1, 2. And then go up to 2. And same with -8. The cube root of -8 is -2. So those are good points to choose. And when we connect these, this kind of looks like the square root function. That. All right, so that's the shape of our cube root function. The domain of this, notice how it goes all the way to -infinity in this direction, right? Goes all the way to positive in that direction. So the domain is -infinity to positive infinity. The range, similarly, just a sec here. Sorry, there, I just had to check one thing. The range on this one, now it doesn't necessarily look like it's going to get up to positive infinity, but it is increasing. So it is going to go up to positive infinity, and it is also decreasing, so it's going to go down to -infinity. Now x and y intercepts, actually on this one, notice it crosses the x-axis as 0, and same with the y-axis as 0. So they're both x equals 0 and y equals 0 as well. And we can get that algebraically if we're doing x-intercept, we plug in 0 for y and solve it. Well, you would get 0 equals the cube root of x, and then you would just cube it, right? 0 cubed is 0. So you could find it that way. Same with y, if you were to plug in 0 for x, the cube root of 0, well, it would just be 0, so y equals 0. So either way, you would get 0 on those. All right, our next function is the absolute value function. This one you're probably not as familiar with, but it's very easy to come up with a graph if you just plug in some values. So if we plug in 0, absolute value of 0 is 0. Remember, the absolute value just makes everything positive. So if we did 1, absolute value of 1 is 1. If we did -1, absolute value of -1 is positive 1. It's going to be here. If we did 2, absolute value of 2 is 2. So it's going to be 2, 2. -2, absolute value of -2 is positive 2. So that would be here. So this one looks like this. These are going to be straight lines. So this one, if you can just remember, it's V-shaped. Absolute value is V-shaped. As opposed to one we'll see in a little bit here, which is more of a U-shaped, and that is x squared. So very important to note that is V-shaped. All right, so the domain, that's the x values. It does go forever this way in the x direction and this way in the x direction. So that would be -infinity to positive infinity. In the y direction, it does stop at 0, but it goes up to positive infinity. So 0 should have a bracket because we can do the absolute value of, absolute value of 0 is 0, right? So it does go to there, but it does not go below 0. X-intercept and y-intercept, actually the same thing here, what we've seen so far. Again, if we move this thing left or right or up and down, which we will in the next section, that will change these intercepts and also could affect the domain and range. All right, the next one is just a constant function, which we'll call f of x equals b. B just represents any constant. So b is just where b is a constant. So for this one, it makes sense to actually come up with a function here. For example, f of x equals 3. That is a constant function. It could be -7, or it could be 1, or it could even be 0. So if we have a constant function, and we're to make a little xy chart for this, well, if we plug in 0, what do we get? Well, there's no place to plug in 0, so the answer is just 3. If we plug in 1, we get, well, 3. If we plug in -1, well, we get out 3. If we plug in 10, we get 3. If we plug in -7, we get 3. Because there's no actually place to plug in an x, so no matter what we plug into this thing, we just get a 3 out. So that means 0, 3 will be here, 1, 3. Right, it's just going to end up being a straight line across 3. So that's the same thing as y equals 3. Because remember, f of x can be switched out with y. So that's like the line y equals 3. Right, the domain of this, well, domain, remember, is x values. It does go to negative and positive infinity in both x directions there, so domain would be that. Now our range for this one, remember, that's y values. And there's actually only one y value that's even defined for this. That's whatever the b is. So the range is actually just going to be a single number, right? It's just going to be whatever number this b is. So the range is just going to be, well, essentially just b. In this case, it would be 3, because that's the only y value that's defined. The x-intercepts, this one actually has none, right? Because it never crosses the x-axis. There is one exception, and that is if this equation was y equals 0. Or, sorry, f of x equals 0. Because if f of x equals 0, then it would just be a straight line across the x-axis. So then that would be it. Y-intercept is just going to occur wherever the b is as well. Since this one was 3, well, then it would just be 3 would be the y-intercept. So in general, we just say y equals b is the y-intercept. So the range and the y-intercept are the same. Okay, the next function is called the identity function. It's called the identity because it never changes. Whatever you plug into this function, you get the same thing out. The identity stays the same. So that's just f of x equals x. It's called the identity function. So if we're to plug in some values, say 0, we plug in a 0, we get out a 0. Plug in a 1, we'll get out a 1. If we plug in a -1, we get out a -1. If we plug in a 2, we get a 2. Plug in a -2, we get out a -2. So this ends up just being a straight line like that. Just a linear equation. Again, if we did some transformations of this, if we like stretched it, maybe shifted it left or right, then may change a couple things, but domain and range of this will actually always be -infinity to positive infinity for both the domain and the range. It goes to -infinity in both directions. The x-intercepts, in this case, it's just 0. X and the y-intercepts are both 0. But again, that could change if we move it left or right or up and down. Okay, next one is the squared function, or this one often called the quadratic function. I'm sure you learned about that in Algebra 2. So if we were to plug in some values for this, start with 0. 0 squared is 0. 1 squared is 1. -1 squared would be +1, because remember, it makes everything positive. 2 squared is 4. -2 squared is 4 also. So this one, 0, 0, 1, 1, -1, 1, 2, 4, -2, 4. This one, be careful when you draw this one. It is a U-shaped more. U-shape, as opposed to the absolute value, which was V-shaped. This one is rounded there at the point. It is not a sharp point, it is rounded. It's very important that you do that. So this is the parent function of x squared. Again, this could be shifted up and down, it could be reflected, could be stretched, all kinds of different things that would change the domain and the range. But for the parent function, the domain of this, well, we can plug in any negative or positive number. Hits every single one. So negative infinity to positive infinity. The range of this, the lowest point there goes as 0, right? The y direction. So 0 to infinity. The only x-intercept there is at x equals 0. Y-intercept also the same, y equals 0. The next one is the cubed function. For all these, just make sure you're making note of the shape as well, because even with the square function, if we add things to it, if we stretch it, it's still going to keep this U shape. Same with the cube function for the next one. If we were to plug in some values here, 0 cubed is 0, 1 cubed is 1, negative 1 cubed is negative 1, 2 cubed is 8, 2 times 2 times 2. Negative 2 cubed is negative 8. So if I were to plot these, 0, 0, 1, 1, negative 1, negative 1, 2, comma 8, here's somewhere, 2, 8, and negative 2, negative 8 down here. This one has this sort of a shape here. So all cubed functions will have that general shape. All right, as far as the domain of this, it's negative infinity to positive infinity. We can plug in any x value. The range, it does go down to negative infinity in both the y direction and up to positive infinity. So that's also negative infinity to positive infinity. And the x and the y-intercepts for this one, again, the parent function crosses through 0, 0 again. So the only ones are x equals 0 and y equals 0. Again, those can change depending on if we shift it up, down, left, right. Okay, and next one is called the reciprocal function. All right, this one probably be the most challenging one that you haven't seen before. The reciprocal function, or 1 over x, generally what I call it. Let's plug in some values here. So first of all, to note, one thing is if you plug in 0, 1 over 0 is actually undefined. So that is actually not even a point we can plot. The reason why is there's actually a vertical asymptote there. Talk about this at some point. There's a vertical asymptote there, which means there's this invisible dotted line that sort of goes down through here, 0, that our function does not cross. All right, more values. If I plug in 1, 1 over 1 is 1. If I plug in negative 1, 1 over negative 1 is negative 1. So let's go through those. If I plug in, let's say 2, 1 over 2 is half, right, or 0.5. Negative 2 would be 1 over negative 2, so that would be negative 0.5. So 2, be like that. If I plug in 3, well, that'd be 1/3 or 0.33. So get closer. And what's going to happen here is these values are going to get closer and closer to 0, but never cross 0. And same with this way. Closer and closer to 0, but never cross it. Now, what's interesting is if you get inside of 1, let's say 0.5. 1 over 0.5, or if I think of it as a half, right? 1 over 1/2, that actually equals 2. So at 0.5, we're actually up to 2. And if I were to do, let's say 1/3, 1 over 1/3 is actually 3. So 1/3, I get up to 3. So what happens in this direction is it approaches here, it's super close, but never actually crosses in that direction. And same with the negative here, it goes like this and never actually crosses the axis. So this is the shape of our reciprocal function. It never crosses 0. There's what we call a vertical asymptote. The domain of this is just a bit trickier. It does go all the way to the negative x direction, right? and all the way the positive x direction. However, there is a spot where it's undefined that's at 0. So the domain for this would be negative infinity up to 0, parenthesis, union 0, parenthesis, to positive infinity. And this says it's defined for every value except for the value exactly 0. So we use the parentheses. For the range, it's actually exactly the same because it goes all the way down to negative y and all the way up to positive y, infinity in both directions. But again, there's a break at 0. There's actually what we call a horizontal asymptote there as well. So the ranges would be the same, negative infinity to 0, union 0 to infinity. For the x and the y intercepts, on this there actually is none. It never crosses the x-axis, never crosses the y-axis. Again, that could change if we shifted it some, but in this case there is none. All right, so that is the end of our library of functions. Again, you need to make sure you know the basic properties of these, make sure you know the shapes, because in the future sections, we are going to be just taking these general shapes and shifting them, stretching them, things like that. So reach out to me if you have questions.